Our next review topic is called Rationalizing the Denominator. I think this is a topic you studied in Algebra 1, but it is likely, or it is possible that maybe you didn't get to it. So this could be the first time you have heard this, and we will practice this procedure when we get to certain aspects in Unit 7. Okay, so I have here at the beginning here just a sentence to sort of set things up. It says, for an expression to be in simplest form, the denominator should not be irrational. So, first of all, rational numbers are numbers that can be expressed in a ratio or a fraction. Irrational numbers, they can't be expressed that way. So, when we're dealing with this topic, when you take the square root of a number, and let's just say the square root of 3, so if I type that into my calculator, I get it's not really a repeating decimal, but it's 1.732050 on and on. Now, if I were to take the square root of a perfect square, say 25, I get 5. So that is not considered irrational. So if you take the square root of a number and you get a decimal, it's considered an irrational number. So we cannot leave our fractions with the denominator or the bottom having a square root symbol in it. Now, if you can take the square root and it's a perfect square, then really it doesn't have a square root symbol in it because you've just simplified it more. So for example, let's look at this first one right here. So the square root of 2 divided by 3. That is fine. You can have the radical symbol in the numerator, all right? So this is good. This is okay. The one over here, though, the square root symbol's in the denominator. So that is considered not simplified form in math. So we're going to talk about how do I get that how do I get that radical out of the denominator? And sometimes we move it to the numerator through a process, okay? So we are going to simplify each expression by rationalizing the denominator. So we're going to create a rational number in the denominator. So on this first one, if you think about the square root of 2, if I want to turn the square root of 2 into a value that doesn't have a square root symbol in it, the easiest way to do that is to multiply it by itself. So consider if I take the square root of 2, so don't write this down yet, just sort of listen to this explanation, and I multiply it by itself, well, what do we get? Well, if I combine those together, 2 times 2 is 4, and I end up getting 2, okay, which is great. That is a rational number. Okay, let's take the square root of 10. So I want to get rid of the square root of 10. What if I multiply it by itself? Well, square root of 10 times square root of 10 is square root of 100, which is 10. So do you see how when you multiply a radical by itself, like we did here, do you see how we always just get the value under the radical, but it's no longer in square root form because we have really created a perfect square? Okay, so I will need to do a couple more things. Now, I can't just change the denominator into a 2. But if I multiply both the denominator and numerator by the same value, that's fine. I haven't changed anything. So if I come through here and say, I'm going to multiply the top and bottom by square root of 2, I mean, the reason I can do that is because I can turn right around and just divide those out and I get 1. All right, so that's why it's okay to do that and you haven't changed the problem. So multiply across the top. 1 times the square root of 2 is really just the square root of 2. Now, the denominator, remember what we just talked about, square root of 2 times square root of 2 is square root of 4, which is actually just a 2. So, in the denominator, I end up with just a 2. This is good. I don't have a radical in the denominator anymore. I have just rationalized or simplified number 1. Okay? So, 1 divided by the square root of 2 is equivalent to the square root of 2 over 2. Okay, so you are multiplying, if you have a radical in the denominator, you're multiplying it by itself, but what you do to the bottom, you must do to the top. Okay? All right, let's try number 2. 7 divided by the square root of 3. So I need to rationalize the square root of 3. So let's multiply top and bottom by the square root of 3. Okay, multiply across the top. So I have 7 times the square root of 3. Now, it's not going to be the square root of 21 because 7 is not under the radical. Okay, this right here, remember, really is the square root of 9, which is actually a 3. Okay, and then the other thing I want to look at is, can I divide those guys out into a whole number? And 7 divided by 3 is a decimal, so we're done here. Okay, so this is my simplified fraction. Okay, let's just keep going. All right, number 3. I am fine with the square root of 5 in the numerator. Okay, I'm not even concerned with that, but I'm not okay with square root of 2. Okay, so let's multiply the bottom by square root of 2, which means I have to also multiply the top by square root of 2. Now, they are both under the radical, so we are going to be able to do, I can take the second step here, and really I can bring 5 and 2 under the radical. When I multiply them, I get 10. Square root of 2 times square root of 2 ends up being a 2. Now, one more thing I ask myself, can this new square root of 10 be simplified down into lowest radical form? And it can't. That's as far as I can go. So I am good with the square root of 10 divided by 2. All right, at any point, if you want to pause the video and start working through them and then come back and check answers, you can. But I'm just going to keep working through just to give you some exposure to different types of problems. Okay, number 4, square root of 3 in the bottom. So I need to multiply both the bottom and top by the square root of 3. So when I do that, the numerator is going to say 12 times the square root of 3. The denominator is now going to be just a 3. And so what I want you to focus on here is these two values can be divided out. So take that one more step, do 12 divided by 3, which is 4. And so you are left with 4 times the square root of 3. Now that worked because what I can do is I can kind of separate. I can do 12 divided by 3 times the square root of 3. Oh, hold on a second. Let me back up. Take that apart. All right, so (12 square root of 3). Let me back up. 12 square root of 3 times the square root of 3. I said that wrong. 12 divided by 3 times the square root of 3. So I'm able to separate the item in blue out like I wrote in red, and then now I can divide 12 divided by 3 because they're like terms. You know, they're both out of the radical. Okay, so sometimes we can simplify one step further, and sometimes we can't. Okay, let's keep going. Number 5. All right, I am going to rationalize the denominator. So times the square root of 8 times the square root of 8. So the new numerator says 8 times the square root of 8. The denominator is just a single 8. Because remember, back over here, the square root, I can do 8 times 8, which is 64. The square root of 64 is then 8. All right, so now I can do a little bit more. I can do 8 divided by 8 here. So 8 divided by 8 is just 1. So I can really just write this as the square root of 8. But there's one more thing to notice. The square root of 8 will break down into a more simplified radical form. So I can turn 8 into 4 times 2. So square root of 4 times square root of 2. Square root of 4 is just a 2. So my final answer here is 2 times the square root of 2. So there's a couple ways to do this problem. I could have come back here to the very beginning and taken the square root of 8 and broken that radical down first into 2 square root of 2, and then rationalize the denominator. Okay, so there's several ways you can do that. It really just becomes a personal preference. And I honestly do it both ways. It just depends on what I notice. Okay, number 6. I'm going to rationalize denominator. So square root of 6, multiply top and bottom by square root of 6. The new numerator is 14 square root of 6 over 6. And then 14 and 6. They don't evenly divide out, but I can divide each by 2. So that leaves me with 7. Now, I am not going to take 2 out of the square root of 6 because I'm not dividing by square root of 6. I'm sorry, I'm not dividing by a 2. Let me back up. I'm dividing by a 2, not a square root of 2. Okay, so they're kind of think of them as not like terms because one's under the radical, one isn't. 6 divided by 2 is 3, and that's it. That's as far as I can go. All right, so there is our simplified rationalized denominator. Okay, one more it looks like. Okay, 20 times square root of 2. So here's what I'm going to do. The only thing I need to rationalize is what's under the radical. So all I need to do is multiply the bottom and top by square root of 2. So I am left with 20 times the square root of 2 over. Now, square root of 2 times square root of 2 here is the square root of 4, which of course is 2. So I'm going to take the new 2 and the 2 that was originally here and multiply those together to get 4. I also can reduce 24th. Actually, I can divide that out evenly. 4 goes into 25 times. So 20 divided by 4 is 5. Square root of 2 is different, so it stays as a square root of 2. Now, I could have, at the very beginning, recognized 20 divided by 2 is 10. And so if I would have done that, here's what my new problem would have been. 20 divided by 2 is 10. So I wouldn't put the 10 in the denominator because then I would have said it was 1/10. So then I could have just continued on like this. And so I would have gotten 10 times the square root of 2 over 2. And then 10 divided by 2 is 5. So I would have gotten to the same point. It just really depends on what you notice first and where you go from there. Okay, so kind of to do a quick recap. All of our answers here, the denominator does not have a square root symbol. Okay, and so that's really the key. So if we kind of come back up to the beginning here, simplest form does not, no radical in the denominator. Not simplest form, you do have a radical in the denominator, and so the way we remove that is we multiply the top and bottom by that particular radical. All right, that's it for rationalizing the denominator.